There we go. So this is the research team. Myself, Isabel, Shadi, and Ricardo. And so this is work we're doing on campus in building a campus verse of all the buildings on campus, old and new and yet to be built buildings. And so we have an effort that goes across a variety of software and platforms from the Gator AI supercomputer to regular computers using either the Omniverse or Tandem or Autodesk Tandem or NVIDIA Omniverse. And we're looking at developing a process to do these conversions. Along the way, we've learned a lot of lessons from, the need for interoperability, which is the main purpose of this organization, the need for common uh, nomenclature and taxonomy, so it can be a seamless integration of building components and data sources and sensors and actuators. So Isabel is going to be the main presenter of this, and I'm going to let her do the presentation. Isabel, it's all yours. If you go back to the first slide and get started.
Sure. So, hello everyone. I'm Isabel. I'm a graduate student at the Rinker School of Construction Management. And as Dr. Isa mentioned, I work with him, Shadi, and Ricardo on our digital twin project, collaborating with Autodesk and the University of Florida with our technical team. Cool. So again, here's our team. Feel free to scan the QR code for a link to our website for more information on kind of what we do and what we research. And without further ado, we have just a short agenda. We'll start off with why digital twins. I'll discuss some opportunities and applications. We'll then go on to Hefner Hall and actually show you of what we've built. And then we'll move forward with challenges and what we interpret the future to look like of our industry with digital twins. So just a little background here. The current climate at the University of Florida, our facilities are old and we have a lot of them. So it is mostly to note that operations and maintenance accounts for around 80% of our building life cycle cost. Our buildings live a long time, especially here at UF, where our buildings define us in terms of architecture and what they stand for. For example, our oldest buildings were built in 1906. They still house students today, and they still have original tile walls and floors. So as our buildings live and breathe, they age just like us, and they begin to incur maintenance needs and other cost and resource allocations that may extend beyond the capabilities and beyond the life of the organizations that operate them. So, to address these challenges posed by aging buildings, the AECO industry has shifted towards sort of a technological approach to solve these challenges posed by aging buildings to save UF and other institutions money and time. So, for facilities and asset management, we're often asked why we choose digital twin technology. So, first and foremost, for facilities management, they do allow us to manage our buildings remotely. So, we do not have to be inside of the building, or we don't even have to be on the campus. Understand what's happening inside of a building and understand what's happening between buildings and how they interact with each other. So our digital twins allow us to diagnose performance inefficiencies so we can predict needs for maintenance. They also allow us to gain a deeper understanding and a deeper insight into the utilization of assets and spaces so we can inform choices that really enhance high efficient performance at our institutions. So you're only able to see so much when you're sitting inside of a room or inside of a building. So we use this technology to look inside the walls, inside the ceilings, and inside the floors to what we cannot see. So shown here is the brief overview of the transformation process from the physical asset to the digital twin. So our raw data is being extracted from the physical building, from, in our case, the building automation system. It is then returned as feedback and usable knowledge for facilities and asset management from the twin itself. So we then go on to our digital twin maturity model. For our sake, our 5 levels include existence, status, operational twin, simulation twin, and finally to our cognitive twin. So each have different data requirements and different use cases that are associated with each. So here at the University of Florida, we currently stand at the status twin stage where we are working to refine geometry and we're working to gather current condition data to use to make decisions. So if we move one level up, our operational twin has the ability to harness analytical capabilities, for example, to identify potential issues, while our simulation twin can actually simulate future performance and reflect the sort of what if scenarios based on what the system has learned over time. So, and finally, we have our cognitive twin, which learns based on historic patterns. And with the help of artificial intelligence and machine learning, we are actually able to make informed decisions on what to do next. For example, for predictive maintenance applications. So the system can inform you that itself. So among the many goals we have with the integration of this digital twin technology, the overall objective is to gain a holistic view of facilities performance while driving campus-wide information consistency. So what this means is this entails knowing more than just the base knowledge about our facilities on campus, but understanding what's really happening in real time and what's happened in the past and how they interact with each other and how each building interacts through time. So this way, we're able to manage, diagnose, predict, and inform decisions for all of our facilities, not just Heavener Hall, as shown here. So the model shown here is in the Autodesk Tandem interface, which provides our solutions for enhancing the facilities and asset management process. Semantic information is attached to assets, which allows maintenance staff to easily find O&M manuals or any warranty information in the event of a system anomaly, a failure, or even an emergency. Well, as you can see, the very transparent and easy to absorb 3D environment allows any professional, trained or untrained, the chance to explore their space and gain a holistic view of performance beyond what they can see and beyond what's happening right in front of them. So we will now go to Heavener Hall. So here we're showing the ability to create and name views based on different trades or highlighted areas or features of the building. You're able to view very realistic architecture on the outside and on the inside of the building. You're able to view internal systems and trace the movement of air. For example, you may have received a work order for a chilled beam that wasn't functioning. You could figure out which chilled beam it is, which air handling unit services that chilled beam. You can figure out all the systems that are serviced by the air handling unit, or in this case, a chosen VAV. So also shown here, you can isolate the rooms being affected by this VAV, and you can view the airflow in between them. You are also able to trace your fire protection You can locate an emergency valve from the exterior, and you can focus on detail down to just a single sprinkler head. So here we're using that same system tracing feature to find the location of the valve on the exterior. You're also able to filter your assets by warranty, by manufacturer, floor, room type, or asset type. They're all neatly organized. You can view your fire rated walls and fire rated doors, and you can hone in on floor by floor performance by displaying heat maps for any parameter that you've made populated in the model, for example, chilled water temperature or discharge air pressure. So, and then you can also focus on a specific asset. You can view its live performance, or you can go back and you can view historic performance points to gain a better understanding of your assets as they age. So now that you've seen what we built, here's our brief outline and how we built it. So if we start on the far left side of this workflow, from the BAS system, we extracted all points that were being tracked in Hefner Hall, and we input them as parameters in Autodesk Tandem. We then created a facility template that contains all these different parameters in Omni class format, which is the desired classification system for UF's facilities and asset management applications. Our live streams of data were achieved through API connections, which allow for that real-time reflection of performance. If we move over to the right-hand side of the workflow, we see our document management system, which is handled by UF. It's directly imported in the model. So you have a very user-friendly interface where you can filter views for different applications. For example, for maintenance, for space and asset management, system tracing, or any real-time analytics of performance. So the Autodesk Tandem environment allows for the realization of these streams of data into one interface. So we're going to focus now on the far left side of the workflow, the building automation system. Here we see the payloads received from the BIS, which are then mapped to the appropriate parameter that we created in Tandem. They are also mapped with a timestamp. Below, the red arrow shows the output streams inside Tandem for the parameters over time. So for our case, we ingest our data every 15 minutes, and we can pull historic data at any time from the BIS. So if we go back to the far right side of that workflow, you can access your asset files and any other documentation by searching the element in the model itself, or you can just zoom in and click on it. Here you can see information related to each asset, such as installation date, your model number, your warranty date, and even your warranty status, if it's active or if it's expired. Any other files can be linked to the asset with a URL, which when clicked on will open that file in a new tab. So for example, you may want to link operations and maintenance manuals, any floor plans, any invoices, or any work order tickets that may have been resolved or submitted for a certain asset over time. So therein lies our summary of opportunities and applications afforded by our digital twin in Tandem for facilities and asset management. We are able to monitor asset health and building performance in real time. So for example, shown here again is a heat map that reflects exhaust air temperature room by room. We are also able to organize our manuals, our cut sheets, or any warranty information that is spatially attached to the assets that they represent. We can also achieve advanced space tracking, which delineates spaces according to room type in a very visual, accessible way, so that we can understand how space is being used and we can inform optimization strategies, which is especially an important thing to note at a college campus. And finally, our digital twins do enable smart decision making with features like our system tracing, as shown here on the top right, where we can determine affected areas in the event of an anomaly or a failure. So for example, again to the top right, we see that chosen VAV and its airflow to the rooms that it services in Heavener Hall. So as we move forward, we cannot realize the future of digital twins without acknowledging the challenges that we encountered to build Heavener Hall and that others may encounter in building future digital twins. So what moved the industry from standard BIM to digital twin was the potential for connecting the entire ecosystem. So our standard BIM, or building information modeling, does continue to enhance the project process here at UF during design throughout construction, but it is not really utilized as there are many challenges when we start to talk about facilities and asset management. So here at UF, we use several different systems that each speak in different ways. And Autodesk Tandem provides a way to integrate all these different streams of information into one environment, enhancing this information accessibility and the ability to make decisions. So shown here is the network of the different systems which are utilized by UF to make our digital twin work and live. Each introduces its own level of complexity, which is adequately managed by Tandem by way of a single integrated information stream. So some other hurdles that may be present in the development of digital twin include our inaccurate models or any undocumented changes, especially when you're working with existing buildings like we did with Havner Hall. So asset information or even models may be outdated or unupdated. For example, you may have clash instances or connectivity um, issues or a room that may have been changed that was not reflected in the model. So all of this makes it harder for us to gather the updated information and the accurate information in order to make a living digital twin. So we are also additionally able to collect our documents from design through construction to project handover. Ultimately, when it is in the digital environment, this is all highly dependent on the cooperation of all stakeholders involved to ensure that this document collection is seamless and it is accurate. So therefore, it is important to establish BIM information requirements for facilities and asset management early on in the design phase to make this process more accurate. So here at UF, we are starting to address this challenge by way of implementing a BEP or BIM execution plan in the design and construction standards. So there we will start discussing digital twin from when the project is bid all the way up until it is a living digital twin in the virtual environment and through operations and maintenance. So as we move forward, we are focused on perfecting our implementation workflow for creating our digital twins in Autodesk Tandem. So it applies to UF buildings, all of them, old and new. We are also focused on refining a user interface for any fault detection, notification systems that you have the ability to alert a user based on a minimum or maximum value that is exceeded for each parameter. You are also able to utilize the capabilities of artificial intelligence and machine learning, which we are focused on for potential fault detection and diagnostics applications. So if we refer back to the 5 levels of digital twin maturity, our goal ultimately is a cognitive digital twin. And finally, overall, UF aims to digital twin the entire campus in a campus verse. where we can leverage insights for any chosen building in order to enhance student experience through efficient facilities and asset management and ensure efficient performance. We are using geographic information systems and other 3D scanning technologies to research this aim, and we look forward to executing it in the future coming up. So here's also some teams that we had worked with. But overall, I'd like to thank you guys for listening. For more information, please contact us or feel free to scan our QR code for our website. So we're very excited about the future of this project, and we hope to elevate it beyond a research initiative into an industry tool that operations and maintenance can use on a regular basis. Thank you, guys.
Thank you.
Thank you very much, Isabel. That's a great presentation. I want to also acknowledge Charlie and Ricardo. Do you guys have anything to add to Isabel's presentation? Any other insights you would like to share with the audience?
I'd like to ask a couple of questions if I could. One of the, do you have a overall status of all the facilities at University of Florida yet?
No.
Okay, because I know that's one of the things that the Coast Guard, U.S. Coast Guard, quite a few years ago attempted something like this. And what they did first was they just set up what they called BIM blobs, and which was basically just a location of a facility and identified the square footage, how many floors and things like that, and that was it. And then what they did was over time identified, and that gave them a scope of how, what they needed to be able to accomplish. And then over time, they identified which facilities that they wanted to, which were more critical, say, to the organization, and then they put higher priority on those facilities. So they were able to, not only understand the scope of the problem, but also to understand how far along they were on the process and how much effort would we take. I'm guessing that Heavener Hall was you had a BIM for that facility? Okay. And that's another aspect of it. Obviously, you don't have BIMs for most of the facilities. So you need to look at how would you collect data on an existing facility also, in addition to the, and again, that's kind of a scoping issue as far as how are you going to accomplish that.
So
yeah.
what we did so far is we use Heavener Hall basically to just to be able to determine the information requirements that we're looking for, that facilities are looking for in a digital twin on UF campus, and we're gonna incorporate that. So Heavener Hall was built probably around 10 years ago. So in terms of semantic data in the model, there wasn't a lot. There was some inaccurate information. So now we're just looking to specify what we want in the BIM execution plan so we can move forward with a more streamlined workflow, basically.
Right. So we're trying to secure perfection in the future with the new buildings and develop a protocol to work with the existing buildings. And of course, I don't think we're going to get all 900 buildings. Some of them are real old, from the beginning of the 20th century. So,
well, those are certainly more difficult, and it may be. And again, what happened with the Coast Guard project is as they went in and did renovations and modifications to the facilities, then they may even do a BIM on the partial or piece of that building. Maybe it's a wing that's getting added on, or maybe it's whatever. And in order to do that project, they still had to collect some basic data about the project as far as power requirements and HVAC and things like that, because you're merging, you're connecting multiple systems. The other question is how much interaction do you have with facilities people at University of Florida?
We actually
go ahead, Isabel.
Yeah, we actually work pretty much hand in hand with facilities. I myself work for UF Planning Design and Construction. So on that end, we are also connected. The important part is to kind of get everyone on board So the hard part was to develop it and make it work. Now we're kind of focused on that next step, standardizing it, make it not only something that we prefer, but something that UF as an owner organization requires for all of its projects, or at least all of its major projects moving forward. So we've been working very close with facilities and also US business affairs team to kind of work through those interoperability issues that I believe Chadi can speak more on if you'd like to.
Well, because
So
also
the
there,
university is committed to this.
well, and that's the issue is that, you know, you got to connect ultimately into the work order system, because every project that gets done on these buildings, and they say renovations or, you know, whatever, those work orders need to be also, you know, there's kind of a rule that needs to be set that you can't close a work order until the model's been updated, the digital twin has been updated. And I
Yeah.
think ultimately, you know, that's obviously easier said than done, but that's kind of, you know, because you mentioned that, you know, trying to keep them up to date, and because they're changing every day. You know,
So
projects
they're reviewing all their protocols from
just-
acquiring new buildings, so everything's getting reviewed. So starting with blue sky on new buildings,
right,
and on old buildings, we're trying to upgrade everything. So we showed you the network diagram with all the softwares the
Right.
university is using that we're integrating in the tandem model.
and hopefully it's just like, you know, Siemens is on one building and, you know, somebody else is
Johnson
on
Control, another one, yeah,
yeah, right, yeah. And of
that's
course,
part of it.
and a lot of those don't talk to each other and all that kind of stuff. But anyway,
Exactly.
Quick question for you, Dagisa. I remember that you mentioned, oh, actually, Isabel mentioned that reality capturing aspects of your team. I know that when Nathan was there, you started to scan some of the existing buildings there and to be able to apply some metadata on top of that.
Yeah.
So I'm wondering, like, what is the workflow when, as Dick pointed out, when you actually scan existing buildings, and trying to turn that into some sort of line of data and actually be able to come up with a model. And additionally, do you use anything in order to actually documenting those metadata? Like, like maybe Kobe. I don't know if you use Kobe or use other formats, or maybe Tandem
Yeah,
can
we
come up with
use
that.
Kobe,
Okay.
but part of this process is we're also documenting a building that was built in the 1950s that they're remodeling.
Mhm.
So we're documenting it before they take it apart, as they're taking it apart, and as they put it back together. So we develop the protocols and insight as to what's going on.
is there any working relationship now with other schools as far as architecture and engineering and things like that for the new facilities?
There is some working relationship.
Okay, because I think that's, as far as the education piece of it, I would love to see some of that happen too.
Yeah, we have an advanced class in the fall that's going to cover
Okay,
all of this.
cool.
And we've had those before. We've written the reality computing manual for Autodesk, training manual, and assignments, instructor manuals, and all those.
And of course, the other question I have to ask is about total cost of ownership. And since that's one of my favorite subjects, because I know that on your model that you did talk about cost, and I'm assuming that probably most of the cost so far is looking at initial cost or first cost, and not necessarily projecting out into the future as far as what costs are going to be coming up for when, and that kind of links in with the master planning and all that to
Yeah.
identify what projects are coming up on these different facilities and when, and ideally when they should come up.
Right.
Are we spending a tremendous amount, or are we wasting a lot of energy on a facility? And that again makes it a higher priority to implement some renovation for it, or and just try to identify some of that. And again, that's kind of working with the work order processes and stuff like that too.
Right. So once the digital twin is in functioning order, we're going to be tracking all this information. So getting a report on the cost is part of it.
Yep. Could be. I mean, it's interesting just to see how it grows too. You know, like you say, how are you going to deal with existing facilities? How are you going to deal with facilities, brand new facilities that haven't, you know, are just being designed?
Right. So that's why we're developing all these protocols,
right.
all these frameworks, and the university is willing and is actually implementing some of these already
Good.
because their mandate, excuse me, is to
So-
digital twins in the future, and so they have to, you know, the more seamless the data is integrated, the easier it becomes. The more common the nomenclature is, the easier it becomes to integrate data.
So, okay, so I'm curious, like, what the work you currently completed, the team has already published there. Do you have like a very simplified version of, they say, dummies for digital twins, etc. If some other campuses wants to exploring, what you have done at the University of Florida, they have some buildings they can actually start to look into that. Do you have any procedures or menus available for them to
We're
actually like, use
developing
as
a white
reference?
paper for
Okay.
Autodesk that's going to be
Okay.
out by the end of this year. That will have all that information.
Okay, and especially the part that Isabel emphasized, that I think it's I think Ricardo emphasized as well, is actually the information requirements, right? What kind of information needs to be collected, what data needs to be entered,
Right.
in what format, that kind of thing. I think that would be critical, because I know that they have some, as Isabel also pointed out, there's different levels of digital twins there. Maybe somebody wants to start with the level 1, at least, it's almost like a LAOD for BIM, right? It's really
Yeah.
similar
So
to
the
that.
LOD 500 is the existence digital
Mhm.
twin, which is the lowest level of digital twin. Then you have the control and the operations and the simulation and then the cognitive. Our goal eventually is to have cognitive digital twins that can, you may have a human in the loop or you may not, that can make some decisions and some alerts and all that.
Excellent.
Yeah,
Any
that's
any
pretty
other
good.
comments, questions?
Any other schools doing similar things? Not on this call today. I know there are, but
I'd like to make a comment on the presentation. First of all, I agree with all the comments made in regard to the presentation. I would like to say that this is one of the best presentations I have seen in my career on this topic. And the team should be commended on being able to put it together in such a way that this is going to advance the efforts of everyone here in this meeting, because of your ability to do so. And I just want to commend you on it. It was very clear. It was very concise. It's very well organized. It's very understandable. And I think this is one of the best presentations I've ever seen. And I want you guys to feel really proud of what you've accomplished, because it's really, I mean, what you have shown 10 years ago was just a dream to any of the people that have been involved in this activity for a long period of time. So I think you're on your way to making major contributions in your own careers in this profession. And thank you very much for showing it today. It's really been a pleasure to see your work.
Thank you.